In this video, we'll look at what happens when we fire a photon through a gas. In the left picture, over here, we will fire a photon, energy level 1. We notice it's gray, and the photon is gray, and it passes through the gas, and it seems to be detected on the other side. It looks the same. When we look at the orbital diagram, we fire that photon through, and it is not recognized by the electron. It is ignored. So this is what we mean when we say that the atom is transparent to that photon. It's transparent. The photon just travels through it unaffected. And it does not matter how many of them we fire. We could sit here and fire all day 1,000. A photon with a particular energy, particular frequency, particular wavelength will have no effect. It will be transparent always. If we increase the energy, fire again, we see it's a different color photon. On the left, we see it's a red photon passing through the gas. And if we notice on the right, with the energy orbital, it again goes through and it's completely transparent to it. We increase the energy to 3. We have a green photon going through the cloud of the gas chamber up here, no effect. And on the orbitals, there is no effect. It is transparent. So energies 1, 2, and 3 are transparent. We go to energy level 4, and we fire. In the cloud chamber, what we see is the photon goes in, it disappears, and then it comes out at a different angle. When we look at the orbitals, to the right, we see the photon being absorbed. It gets excited, jumps up to a new level, and then re-emits the photon, the same energy, the same color. So again, the photon comes in, it's absorbed, the electron's excited, and then it re-emits the photon and drops back down. So we have absorption, and then we have emission. The electron absorbs the photon, and then that photon is emitted. And we go to energy level 5, repeating the same thing with the cloud chamber, transparent. And again, it doesn't matter how many times we do it. If it's transparent, it's transparent. And if we go back down to 4, if it's absorbed, it will always be absorbed. So we can now go to energy level 6. Again, transparent. Seven. Aha, it's excited. And notice this one, it jumped to the n=2 level. So the energy is greater going in. It jumps to a higher excitation state, to n=2. And, excuse me, the n=3, the light green. And it emits a photon. Now, in the first case, we saw that it emitted 1 photon equal in light. Let's look at the gas chamber. Notice it emits 2 photons. And if we look at the cloud chamber again, the next time, it emits 1. So looking back at the orbitals, if the electron is excited to the n=3, it can either emit and drop back down to the n=1, or it could emit 2 photons from n=3 to n=2 and n=2 to n=1. So there's 2 distinct possibilities there. Now when we go to energy level 8, transparent, 9, transparent, 10, transparent, 11, transparent, 12, transparent, 13. Aha, it jumps to the n=3 level. It's excited to the n=3, gives off a photon and drops right back down, gives exactly the same energy. So watch the cloud chamber. That one gave off 3 distinct energy photons. So looking back at the energy level diagram, if it's excited to n equal 3, it could jump all the way down. It could jump to the n equal 2, excuse me, from the n equal 4 to the n equal 3. It could then jump from the n equal 3 to n equal 2, and from the n equal 2 to n equal 1, or n4 to n3, and 3 to 1, or n4 to n2, and to 1. So we'll watch that again. That was a drop all the way down, so that was an n equal 4 to, or n equal 3 to, n equal 4 to an n equal 3 to a 2 to a 1. So that's 3 distincts. And that's from the 4 to the 2 to the 1. 4 to 3 to 2 to 1. 4 to 2 to 1. Go up to level 14. Transparent. 15. Transparent. 16. Transparent. 17. Transparent. 18. Transparent. 19. Excited, jumps to the n equal 5, emits to 3 to 2 to 1, gives off 3 different photons in that decay. Again, excited, 5 to 3 to 2 to 1. And again, 5 to 4 to 1. 5 to 3 to 2 to 1. And then we get to 20. And we are transparent again. So this is the process of photon absorption, electron excitation, and then photon emission. And what we can see then is that a photon will come in with a certain amount of energy. The energy that's emitted can be exactly the same or less than what was originally emitted. But if it's less, it will emit at least 2 photons.